Hello, eighth grade. Today we're going to use what we learned last week about solving equations that contain integers and apply the same thinking to equations that have fractions and decimals in them. So now these are a little bit more complex in that the computation might be a little bit more challenging, but the procedure is actually the same. So that's why it's so important to get into that routine of understanding the procedure and applying it every single time. So I'd like you to do these problems along with me, please.
Hi, please call extension 13 if you're trying to call the office.
Okay, let's try that again. Here we go. First problem is n plus 4 5/10 equals negative 9 7/10. So our goal is to find the solution to the equation, which is the value for n that makes this a true equation. So we want to isolate n. So we need to create zero pair with this 4 5/10. And we do that by subtracting 4 5/10. And if we're going to do that on one side of the equation, we do it on the other side of the equation also. Okay, so now on the left-hand side, this creates a zero pair. So all we have left is n. And now we have to combine negative 9 7/10 with negative 4 5/10. Now I said combine. You could think of it as a subtraction problem, but really it's two negative quantities being put together. So that means the result's also going to be negative. It looks like that would be negative 14 2/10. And once again, we want to verify that that answer works as the solution. And so we could put negative 14 2/10 in for n. We could add 4 5/10 to that, and we should get negative 9 7/10, and that looks like that is true. So I'm going to check it off and say, good job. So same thing holds true with fractions. If n minus 3/4 equals negative 5/8, again, we want to isolate the variable, and we would do that by adding 3/4 to both sides of this equation, because we create the zero pair here, which is what our goal is in order to isolate n. So now we have one positive and one negative quantity, and so we know that to deal with that, we have to really find the difference between them and think about whether it's going to be positive or negative. Now, before we can do that, we really need common denominators. So I would say that because 8 is a multiple of 4, that we multiply this by 2/2 and make it eighths. So now we have a positive 6/8 and a negative 5/8. So if you have a positive 6/8 and a negative 5/8, you could write it as a subtraction problem, and the difference is 1/8. Okay, and so now I'm going to check that by saying 1/8 minus, now I know 3/4 is equal to 6/8 is equal to negative 5/8. Does that make sense? Just want to make sure you can see it. Yeah, because they're the same size part. 1 minus 6 is negative 5, so this is a good solution. Okay, so take a look at this problem. 9/10 x is equal to negative 5 4/10. Negative 5 4/10. Now, I'm going to show you a little trick to make this problem easier to solve. And I'm going to add a step, but it kind of saves you a step later on. And that is, when I have a coefficient, this negative 9/10, this coefficient is a decimal number. Well, I don't really love decimal numbers, so I want to make this a whole number. And if I make this a whole number, then it's a simpler problem to solve. So what would it take to make 9/10 a whole number? Well, if I multiplied this quantity by 10, right, 9/10 10 times would be 9, because everything would shift one place. 9x is going to be a friendlier value to deal with. Now, if I'm going to do that on one side of the equation, I must also do it on the other side of the equation, right? That's how we keep balance. So negative 5 4/10 times 10, again, all the digits shift, which would be equal to negative 54. And now that's just a simple division problem, right? To get rid of that 9 coefficient, I need to divide this side by 9, which means I need to divide this side by 9 also. So 9 divided by 9, we know is 1. So we have a single x left. and negative 54 divided by 9 is negative 6. So now I just need to check to make sure it works. So I'm going to go back to the original equation, which was negative 6 times 9/10. I did not write that very well. Let's try that again. If I put 9/10 times 6, negative 6, would we get negative 5 4/10? Yes, we would. So that is correct. So the key on that was making the coefficient a whole quantity to make it easier to solve. And trust me, you're going to want to do that whenever you have the opportunity. Okay, in this problem, we have m being divided by negative 7 2/10, and that is equal to negative 12 5/10. So to get to isolate the m, we have to use multiplication because right now it's being divided by, and to offset that, we would multiply by the same quantity. So we will multiply that side by negative 7 2/10, as well as the other side of this equation by negative 7 2/10. So those would simplify away and isolate the m. And now we would just need to multiply. And that multiplication would give you a product of positive 90. We have a negative times a negative, which is positive, and then 12.5 times 7 2/10 is 90. So now let's check it. If you take 90 and put it in for m and divide it by negative 7 2/10, you do get negative 12 5/10. I am not going to do that division, but you should, as you are verifying that your answer is correct. All right, so let's take a look at a multiplication problem involving a fraction. 5/8 is equal, 5a's is equal to 1/7. So now, typically when you have a coefficient that's a whole number, what you would do is divide by that same coefficient, because 5 divided by 5 is 1. Now, if you're going to have a fraction and you're going to divide it by 5, we really need to think about what it means to divide with fractions. And so, you know, you learned in 6th grade this kind of shortcut. But before you use the shortcut, I really want you to understand why it works. So let's take a break from this for a second and think about division with fractions. So let's say we had 10 and we wanted to divide it by 1/2. Well, what does that mean? It means how many 1/2s are in 10. That's what division is. Another way of saying division. Well, how many 1/2s are in 1? Just a half. How many are in 2? Or how many halves make a whole? 2 of them, right? So for every whole, we have 2 halves. So for 10, that means we would have 20 halves, right? 20 halves is equivalent to 10. Now, what does that look like? Well, it kind of looks like 10 times 2 is equal to 20, right? So what you learned, the shortcut is that you could take a dividing by a fraction problem and turn it into a multiplication problem using its reciprocal. The reciprocal of 1/2 is 2. The reciprocal of 2 is 1/2, right? You just flip the numerator and the denominator. So back to our problem here, 1/7 divided by 5 is the same as saying 1/7 times the reciprocal of 5. 5 is thought of, if you want to think of 5 as a fraction, it's 5 over 1. So the reciprocal would be 1 over 5. So now we already made this, this is just A. We have A is equal to 1/7 times 1/5 means A is equal to 1/35. Now let's go back to the original equation and see if that makes sense. So I'm going to rewrite this, I think. The original equation said 5A is equal to 1/7. Well, if A is 1/35, does that make sense? Yes, because 5 times 1/35 would be 5/35, which would simplify to 1/7. So it is a true equation. Okay, so what do you think happens if the coefficient is a fraction? Well, really the same thing, but instead of thinking of it as division, we're going to think of it as multiplication. So really, what would we do to get rid of this coefficient of 4/5? We would divide by 4/5, right? Well, what does it mean to divide by 4/5? It means to multiply by 5/4. So we could skip this step of thinking of it as a division problem and just go straight to multiplying it by its reciprocal. Now remember, we could do anything we want to both sides of this equation, as long as we do it to both sides. Our goal is to get rid of that coefficient so we have an isolated variable. So if we want to get rid of 4/5, we could multiply it by 5/4, and any number times its reciprocal will give you 1. So this would then isolate the m. Now, if we're going to multiply that side by 5/4, we also have to do it over here. And I can see that we can simplify the 5 by a factor of 5, the 10 by a factor of 5. And so now we have 9 times 1 is 9, 2 times 4 is 8, 9/8 would be the solution to that equation. And we can double check that by looking at the original. 4/5 times that 9/8 should give us 9/10. And I don't want to just go through the motions here. I want to make sure that I have the right answer. So I'm going to simplify this multiplication to 1 and 2. And you can see 1 times 9 is 9, and 5 times 2 is 10. So our solution was a good one. Okay, so I'd like you to try these problems on your own. I tried to make the numbers as consistent as I could because there are 4 different pages that we're working with. But follow the procedure and check your answers and you should be fine. But remember, you need to show every step of your work. Then upload it to Google Classroom so I can take a look. Okay, thank you.